Yo, what's up everyone? Welcome to Thermodynamics Part 2. Today we're going to be talking about heat. So what is heat? Heat is going to be energy transfer between systems due to a temperature difference between them. And heat and temperature are really used colloquially as the same thing. But in chemistry, heat and temperature are not the same thing. If you look at temperature, temperature is based on the random motion of particles. If particles are moving really, really fast, we say that the temperature is really high. If they're moving really, really slow, then we say that the temperature is really cold. Heat, on the other hand, involves a transfer in energy. And in order for an energy transfer to occur, there must be a temperature difference between two systems. So one system must be hotter than another system in order for heat to be transferred between them. Although they're not the same thing, you can relate temperature and heat. And the way that you connect them is using this equation, which tells you that Q, which is heat, equals to mc, mass times specific heat capacity, times the change in temperature. Q equals mc delta T. Now, we know what all of these are. We know what heat is, we know what mass is, we know what a change in temperature is, but we don't know what specific heat capacity is. Well, heat capacity is going to be the amount of energy required to raise the temperature of a substance 1 degree Celsius, sorry. Now, the problem with heat capacity is that it doesn't really specify how much of a substance. So you could take 10 grams of a substance, or 20, or 30, or 40, and it would still be at heat capacity. We like to use the specific heat capacity, which is the amount of energy required to raise the temperature of 1 gram of a substance 1 degree Celsius. And the specific heat capacity of water is 4.18 joules per gram times Celsius, which means that it would take 4.18 joules of energy to raise the temperature of 1 gram of water 1 degree Celsius. And so if you were to do an experiment in order to find all your components here to find heat, you would do your experiment in something known as a calorimeter. So this over here is called a calorimeter. And this specific one is called a coffee cup calorimeter. The reason we use a coffee cup calorimeter is because styrofoam is really good at insulating all the heat, so all the heat that happens in a reaction is contained in the container. So what we do is that we take a bunch of reactants, we measure out reactants, and we put them inside the styrofoam container. We make sure to put the lid over it, make sure it's really well insulated. We have a thermometer to measure changes in temperature, and we also have a stirrer, which helps the reaction happen faster. So what happens is that as the reaction happens, based on whether or not the reaction is endothermic or exothermic, the substance is going to have a change in temperature, and we can measure that using the thermometer. So we know our change in temperature. We're going to know M because that's going to be based on what reactants we put in. So we're going to measure out reactants and put them in there. And we can also know C because it's a property of our reactant that we're putting. So we can find out all three of these values and then plug them in and find the total heat. And this is all done in a calorimeter. Let's do one more example. A sample of 54 grams of methanol is heated from 25 degrees Celsius to 35 degrees Celsius. How much heat is required? And we're told that the specific heat capacity of methanol is 2.48 joules per gram times Kelvin. We know that Q is equal to mc delta T. And we know a lot of these values already. We know our M is mass, so our mass is 54 grams. We're told that in the problem here. C, that's our specific heat capacity, and we're told that the specific heat capacity of methanol is 2.48 joules per gram Kelvin. And then our delta T. Technically, we should do our change in temperatures in Kelvin since our unit here is Kelvin, but it's going to be the same numeric value if we do it in Celsius or Kelvin. So let's just cheat a little and use Celsius and just put a Kelvin at the end. That's totally wrong, but it's fine. And so if you do all the math out here, that's going to be about 1,340 joules, which is answer choice C, which is the right answer. And that's all I have for this video. I hope you were able to learn something about heat. Thank you for watching, and I hope to see you later. Thank you.